This principle acts like the system's own internal weather vane, constantly gauging the winds of change within. Sensing regulators are like diligent but forgetful librarians. They're excellent at noticing the book's variables that are out of place right now, but don't remember the last book they put back on the shelf. Their entire world revolves around the here and now of internal conditions, constantly adjusting things on the fly. It's as if they're perpetually tuning a guitar that never stays in tune, responding only to the current string's twang without any regard for the melody played a minute ago. Limerick for sensing regulation. In a system that's never quite static, sensing regulators ever ecstatic, adjust on the spot, remembering not, in a dance that's almost acrobatic. The free energy principle is a fascinating concept in neuroscience and theoretical biology proposed by Carl Friston. It posits that biological systems like the human brain maintain themselves and adapt to their environment by minimizing free energy, which is a measure of uncertainty or surprise about sensory input. This principle can be applied to understand how each of the previously discussed principles operates within a system. Let's explore each one in the context of the free energy principle. Under the free energy principle, the role of sensing regulators can be seen as minimizing uncertainty about the current state of internal environmental variables. These regulators are constantly updating their perception to reduce the surprise or unpredictability of the system's internal state. By doing so, they effectively minimize the free energy associated with internal conditions, ensuring the system's stability and efficiency. Adaptive baselines are like the wise elders of the system, drawing on tales of yore, historical data, and today's gossip, current conditions, to advise on the best course of action. They're the keepers of the system's set points, which are like the secret recipes passed down through generations. These recipes aren't set in stone, though. They evolve, taking a pinch of the past and a dash of the present to season the future. Imagine a chef who's not just cooking based on what's in the pantry today, but also remembers every meal ever made and every guest's preference. Limerick for adaptive baselines. There once were baselines quite adaptive, in a world unpredictably active. With a historical glance and a present-day dance, their adjustments were rather attractive. Adaptive baselines, which dynamically adjust set points based on historical and current data, align closely with the free energy principle. By incorporating both past experiences, reducing historical uncertainty, and current data, minimizing present surprise, these baselines help the system maintain a state that is least surprising or most predictable. This ongoing adjustment of set points is akin to a system's continuous effort to minimize its free energy.